Hello guys, in this video we are going to solve sine inverse square root value of x over a plus x. To remove square root value, we can give a substitution. We can substitute x as a tan square theta. Then differentiation with respect to theta. Differentiation of the x we can write as dx over d theta. Simple a into differentiation of the tan square theta we can write as 2 tan theta to the power of 1. Finally, differentiation of the tan theta we can write as sec square theta. Then we can cross multiply denominator value d theta and we can subject dx value as 2a tan theta into sec square theta into d theta. Let's move to integration part. Integral sine inverse square root, instead of x value we can substitute a tan square theta. Instead of dx value we can substitute 2a tan theta sec square theta into d theta value. We know 2a is a constant term, so we can bring 2a outside of the integral. Then we can write 2a integral sine inverse square root a tan square theta. In the denominator we can get a as a common term. Then we can write a into 1 plus tan square theta, tan theta sec square theta into d theta. We know 1 plus tan squared x equal to sec squared x. So in here, instead of 1 plus tan squared theta, we can write sec squared theta. After that we can cancel out denominator a value and numerator a value. Tan squared theta over sec squared theta we can write as tan theta over sec theta perfect squared. After that we can remove the square root value. Now tan theta over sec theta. Tan theta means sin theta over cos theta. Sec theta means 1 over cos theta. After that we can cancel out cos theta terms. Then we can write sin theta as the final answer. X. So in here sin inverse sin theta value we can take it as theta. Finally, to simplify this integral theta tan theta sec square theta d theta, we can use integration by parts method. Integral fx to the power of n into f dash x value we can get as fx to the power of n plus 1 over n plus 1. Here f dash x means differentiation of the fx. So in this integral we can write tan theta to the power of 1 into sec square theta. In here fx just like tan theta, n just like 1, f dash x just like sec square theta, because differentiation of the tan theta equals sec square theta. Now we can give priority for these terms. Then we can write tan theta perfect squared over 2. In here n plus 1 value equal to 2. We can write theta term as it is. Now minus integral tan theta perfect squared over 2 into differentiation of the theta value. Differentiation of the theta value we can write as 1. So we can write 1 over 2 into integral tan squared theta d theta. We know tan squared x equal to sec squared x minus 1. So in here tan squared theta value we can write as sec squared theta minus 1. After that we can get integration sign separately. Integral sec squared theta minus integral 1. Integral sec squared theta equal to tan theta. Integral 1 equal to theta. Finally, we need to express these tan theta and theta terms from x terms. First one, x equal to a tan squared theta. So we can write tan squared theta as x over a. And tan theta equal to square root value of x over a. So we can subject theta as tan inverse root x over a. First one, tan squared theta. Instead of tan squared theta we can write x over a. Second one, theta. Instead of theta, we can write tan inverse square root value of x over a. Instead of tan theta value, we can write root x over a. Finally, instead of theta value, we can write tan inverse root x over a.